My name is Ryan Edwards. I will be your MC for tonight, but I will not be your speaker. Your speaker is the one and only Chris Jordan right behind your back there, guys. He'll be talking about analyzing data, looking at evidence in the paranormal field. I want to say I appreciate all you guys coming out tonight. It's great seeing all your faces. So thank you for coming out. Chris will be taking over because I only have so many words.
Thank you so much, Ryan.
I have the looks, he has the words.
Hi, everybody. I'm Chris Jordan. Thank you so much for coming out tonight. Yeah, man, it doesn't seem like we've been doing Symposium for a year now, but we have been. So thank you guys so much for making it out there. Are anybody out here actual paranormal investigators right now? Or is this something that you're just interested in? Or you are an investigator right now?
Yeah.
Okay, great. Awesome. Well, hopefully we will be getting into a few things that you may be familiar with as far as analyzing data and evidence. I'm actually the founder of Curious Research, and part of what we do is help bridge the gap between science, paranormal studies. This has been an ongoing thing for a long time that oddly enough is coming to a head right now. The whole fight between paranormal and science. It's funny to see so many communities now that science is actively coming to. You know, since quantum entanglement won the Nobel Peace Prize a couple years ago, science has a whole new interest in a lot of the things that have always been in the Kleenex bin of paranormal. And you may hear me use that term a few times. I use it on my show pretty regularly. And I use that because, you know, we have a tendency as people, even as investigators, to lump things together into like places. And when you say something like Kleenex, well, somebody's normally asking for a tissue. The problem is science doesn't like us just saying every tissue is a Kleenex. Because there's double ply, single ply, lotion, done lotion, scented, unscented. There's brands other than Kleenex. So what science likes to do is categorize things. That's literally what they do, whether it's kingdom, phylum, species, what have you. They like to be able to take independent pieces of data, tie them together, call together information. We have a few problems, though, when it comes to the mentality sometimes of whether it's paranormal, UFO, UAP, cryptid studies. Once again, there's a very us versus them mentality, and that sets up a few situations, sadly. It sets up a fear-based system, number one, where every paranormal investigator feels as though a scientist will not listen to their evidence. Well, you start using words like data instead of evidence, they suddenly start listening a whole lot more. Because now you aren't coming to them with a solution, you're coming to them with a question. I have data that is anomalous. I'd like you to examine this data. When you come to somebody, an investigator of any kind, whether it's police, scientists, and say, I have evidence, that means it's already passed through that chain of science. It's already been double, third guessed. It's already been through that process. So the environment of cooperation gets robbed a lot. And especially with social media, things get roiled up really hard. We saw that just in this last year with the UFO UAP panels, where at the second panel with NASA, the head of the panels had to get up and ask people to stop emailing threats to NASA scientists. Like, these people just joined this panel. They actually just joined NASA 5 years ago. So they are not aware of any 25-year-long conspiracy theory that you think that they're a part of. So yeah, when you come to science with that, it's a little hard for them to want to be involved. So we kind of have to consider that as the us versus them, and how far does that get us? And when it comes to actively looking at things through a scientific method, we have to realize that, yes, science is lacking, but so are we. You know, we have to be willing to look at things once again in the same light that they do, dispassionately look at the photos we get, have a good research partner, which we'll get into here in a few minutes, things like that. But what science forgets a lot is that it all starts right there. Observation and question. So the second you have had a paranormal experience, doesn't matter if you saw Bigfoot in the woods, doesn't matter if you had an EVP that you captured on investigation, doesn't matter if you saw a UFO in the sky. As soon as you have experienced that, you're now a citizen scientist. Science began. You have observed something and you've had a question. The only difference now is if you begin to research the topic more. And then from there, if you have a hypothesis or an idea of what your experience may have been. So the only question is whether or not you bought a ticket to the science train. Like, science started. As soon as you had your experience, you are a citizen scientist. So start gathering that data as soon as you can. Write it down as soon as you can. We'll get into the observation log later, which this is the front cover of. But I wrote the observation and encounter log for investigators in the field because, well, frequently we get pictures, we get videos. We'll get into some of that in a minute. And as experiencers, and I say we because I've had my experiences. As experiencers, we take on a huge part of belief, a huge part of belief. But with that belief should also come a greater realm of want of data. You should also, your realm of what you consider evidence should also raise in equal measure with that realm of belief that you've gained. And the filters of belief and experience do a lot of things to us. One of the examples I give all the time is I have an older brother. He's about 4 years older than me. You go to him, you ask him what Christmas in 1985 was like. He's going to give you a different experience. We may talk about the Castle Grayskull that we had to share as brothers. But his experience, the way it impacted him, the way it emotionally made him feel, is totally different than my experience. And we grew up in the same house and we had the same Christmas. So when you start looking at the filters through which we view things, how we view things, this comes down to preparation for an investigation as well. You know, if you are coming at an investigation with a scientific point of view, you should have a rote checklist of equipment. And do I have the directions to my location? And I think that's it. I don't think you should be going down rabbit holes of watching YouTube videos the night before your investigation, things like that. You should maybe be familiar with a few facts of the location. But when you start going down the rabbit hole of those things, when you start watching things before you go out on investigation, you're polishing that filter. You're now looking for something before you ever get there. And that's not science. So you kind of have to go with the, hey, people have had an experience. Maybe we will, maybe we won't. But let's make sure we look at this and gather data in the field in the most scientific way possible, you know. And that's where we start getting into data versus evidence. This is something that I'd almost say I soapbox preach about regularly on my show. And that's probably because I've spent time in the back of a police car. I've spent my night in jail. That is why I'm all about evidence, because evidence is something, as you can see, it is something which shows that something else exists or is true. So that's not necessarily a point of data, which data is something totally different. Facts are information used to calculate, analyze, or plan something. So if you've taken a picture on investigation, what you have is data. You have data that still needs to be analyzed. And even despite, even if you've been doing it for 10 or 15 years, even when I examine something, I have people that I bounce it off of. I have people better than me at audio video to bounce things off of. I've been doing audio video work with cameras and video cameras and editing and special effects photo restoration, forensic audio restoration, things like that for almost 30 years of my life. So when it comes to things on a camera, I can spot a lot of anomalies pretty quick. I can explain them. Same thing with audio anomalies, stuff like that. But there are still things that are out there. And we have to be willing to admit that the minute something becomes regular or ordinary, it is no longer paranormal. It's just normal. So if you're going to a location and getting something all the time on a Wednesday night, you may want to take that into your data set. Like there's actively somebody who will remain nameless. I refer to them regularly, but they're in one of the UFO groups on social media. And they post videos about 2-3 times a week from right here in San Antonio. Now, when you ask them where they're at, their location triangulates, well, almost between San Antonio Airport, the military base, all kinds of things. But the real question comes in the fact of, wow, you post videos on Thursday morning, and they're always recorded between this time span on Wednesday night. You post videos on Saturday, and they're always recorded between this time span. So that seems like a regular scheduled event at that point. And we have to be willing to take that data into consideration. That does not remove your experience. And we'll get into that here in a few minutes. But what we do have to realize is that whether it's data, whether it's evidence, whichever point we're at, we have to be ready for the fact that our brains are pattern machines. This is what has evolved over millions of years. Millions. And evolved for survival. There's a reason why we learn faster that fire will burn you than how to build a fire to cook an egg for survival. You'll learn that fire hurts you faster and retain that faster than you will ever retain how to build a fire. Because one of them is about survival. The other is about possibly cooking food, So we're wired to recognize patterns. We're wired to recognize things that look familiar to us. And once you get into that idea of pattern recognition, that's where we start getting into that phenomenon of pareidolia. Most investigators are familiar with this. This is the mind's tendency to recognize something familiar, like the face in this cloud. Well, I see a face. Had I said nothing, would you see a face? So we have to be willing to admit that if somebody is posting leading things online, stuff like that, and we'll get into a few actual social media pictures at the end of this that are actively making the rounds right now. One of them, which is not in this because it just started hitting the wires this morning, late last night, is 3i Atlas. Anybody familiar with 3i Atlas right now? That is the interstellar comet. Its designation 3I being third interstellar object detected by the Atlas platform, which is our new astronomic detection platform for detecting near-Earth asteroids, things that may be dangerous to us. There have been a swell of pictures over the last couple days. This is the latest picture. This is the latest picture from James Webb, and it's not. It's fully not. It is an AI'd picture of something that was like the world killer in a Star Trek episode. The actual picture, even compiled from 3 different things, is literally a tiny fuzzy little ball that you cannot make out against a background of moving stars. And these images being posted by actual investigators, people from agencies with letters behind them in the world of UFO UAP, are posting them as though they are real. That's how easy it is. That's how easy it is to be willing to go down the road, to be willing to accept something as though it is real, even though it may not be. One of the greatest examples of pareidolia was Old Man of the Mountain. This was a national monument that actually just in 2017 collapsed. But there's a national park around that. And like I said, we'd be getting into things like red circles. I'm a big fan of red circles because I'm a big fan of science. Once again, even if what is explained in your red circle, or even if what's in your red circle is explained, that does not remove your experience. That doesn't remove the moment that you found something in your picture that, just like we said in the scientific method a while ago, made you ask a question, took you down the road of investigation into the topic further. It took you down the road of science. And just because what is in this image is explained doesn't mean that you haven't contributed to what is now the known quantitative of a scientific field of study, which only narrows the possibilities of paranormal. So when we know more about the known quantitative, then we know more about the anomaly. We know what not to look for. And the more we know what not to look for, the more what is odd stands out. So never be afraid for somebody to explain what is in your video, what is on your photo, what might be in your recording. It's okay. It's all right. Science has a phrase called killing your darlings, where basically if you have formed a hypothesis, it's your red team over here, your other scientists in the lab that are supposed to literally try to poke holes in that, and so many holes that it sinks. That's the hope, is that the hypothesis sinks. If it floats, well, now we have something. And we need to give this to another lab to look at independently and see if they poke more holes on it, if it'll still float or if it'll sink. So once again, if you don't see data, if people are unwilling to give you data, ask questions. If you saw this online and all I said is, if you notice down at the bottom, Christopher Jordan, I recorded this. Now, if all I did on a social media group was say I recorded this in my backyard last night, you'd probably see a whole bunch of people hop on the train of, I've seen those light orbs. I've seen that. I've recorded the same thing in my backyard. Now, if I give you actual data of, I recorded this in my backyard, April 2023. My camera was on an 8-inch telescope that was not tracking on its base yet, unfocused, pointed 18 degrees over the southeast horizon. You could probably pretty quickly decode the fact that that is the dog star Sirius, unfocused in the telescope. The only reason it's moving is because the tracking on the telescope is not locked into it yet. I was busy centering it and focusing it to lock it in. That was the third star to be able to track planets and track. So what you're seeing is the actual rotation of the Earth in real time, exaggerated by 8 times. That is the actual rotation of the Earth that's making that object move. The only thing that's making it throb is the actual aberrations of temperature layers in the atmosphere. It looks hollow like that because it's out of focus. And it throbs those colors because the dog star Sirius naturally fluctuates between red, green, and blue. So once again, not given data, we have a problem. And it's very easy to follow down a rabbit hole that may not be the case. So if somebody is unwilling to give you data, hey, what camera did you use to take this? That's important. That's important. Perspective is important. This is an example of what's called forced perspective. I'm sure we've all done something like this. But forced perspective is where you purposefully put an object out of perspective to the object in the background in order to make it look larger. Things like that. These are regularly used for hoax photographs, that kind of stuff. Once again, another example of forced perspective is just not giving people data. Now you look at this interesting thing hanging on this fireplace. You can see it move. You can see it move back and forth, and it starts swaying pretty decently, even despite camera sway. Now, you take that same video and zoom it out, you can clearly see not only Tropic Thunder on the TV, but also the ceiling fan, which is actively moving the object. So forced perspective and leading you down a road of look at this thing that was found removes the scientific data. And the problem is our brains are literally made to follow these rabbit holes. They are made to take random pieces of data and associate them together. This is literally a function of our brain. This is what makes us ingenious people that can take a coconut and turn it into a radio on Gilligan's Island. Things like that. But in all sincerity, it is what makes us ingenious. It's what allows us to miniaturize things so they can go into space, stuff like that. But we have to be careful because not only do we have that pareidolia that's there, always haunting us, something familiar, but we also have apophenia. And apophenia is pareidolia on steroids. That's where you start getting conspiracy theory. That's where you actively start tying threads together between non-related pieces of data. An example of this would be, you know what? Every single time there is a fire, there's the fireman. You ever considered the fact maybe they're starting fires? Like, no, that's a pretty illogical thing. But there are some people who would take that road and go down it and keep going down it. So we have to be willing to accept the fact that, yes, while our brain receives all these things, it's also a filtering machine. And we have to be willing to filter that data. We have to be willing to cull data. We have to be willing to say that even data that we have found may not be worth looking into, you know, and that is where research doesn't happen in a vacuum. That's where a research partner comes in. That's where having somebody who's willing to ask you hard questions and who you're willing to listen to hard questions from. Because that isn't everybody. I love my wife. I love her to death. But when I ask her to edit something, I take it 180 degrees different than when I ask my brother to edit the exact same piece of material. And that's another example of that filter and how we receive data from people. You know, she's done nothing more than do exactly what I've asked, which is to edit something. But my filter looks at it differently than when another person edits it because of the trust barrier between us. So we have to be willing to accept those things, and we have to be willing to accept that sometimes we need another person to be able to ballast us out. We need somebody else to be able to call us out and say, hey man, I think you missed this. And that's okay. That's all right. Because once again, science doesn't happen in a vacuum. We did not get to the moon because of one dude. It's not how that works. Now, let's start getting into toys and examining things like that. One of the big ones is EMF meters. Anybody here own an EMF meter? Nice. I'm about that. Now, there's a few things with EMF meters. Number one, knowing the spectrum is actively important. Knowing the electromagnetic spectrum, understanding the fact that we see and hear and process a very minuscule part. Within that visible light spectrum is also the 20 hertz to 20,000 hertz that your ear range is at. So there's a lot of the spectrum that we don't pick up, especially when it comes to electromagnetic frequencies. Once again, this little range right here, between 20 and 20,000 hertz, that's all we hear. That's it. So there's a whole range of things that gets picked up. a whole range of super low ELF frequencies, things like that. And the issue that you have is when you start looking at detectors like this, which are very common, and yes, they come with a chart inside. They do come with something that tells you how to read it. But even that is very, very general. And there's no way you're going to be able to, between two red lights and one closer to yellow, be able to actively tell what frequencies you're accounting like this will. So this is an actual zeroable. Zeroable, just so you know, if you see that, or I forgot the other description offhand, adjustable would be one. That basically means that when you get into an environment, you can set a base level. You cannot set a base level with this. So while this is good for general things, stuff like that, if you're trying to get into detailed data and start getting into what frequencies are actively interacting around you, things like that, you need a much more scientific device. You need something where you can actually zero it to the environment, where you can actually get a precise reading in decimals, things like that. Same thing with audio recorders. The one on the left here is literally like, I do not leave home without that. It is with me 24/7 if I have my backpack with me. I'm a musician, poet. I've always got a recorder with me of some sort. The other is a full-on professional. You can get much better recording out of it. And the difference really comes down to the microphones. The microphones that are there, the size of the diaphragms, things like that. And when you look inside of the specs, if you don't have specs, even if you go to Amazon, I bought both of these items off Amazon, both of them. This one does not have as thorough of specifications as the Tascam. The Tascam is made for active field recording. It is made to go out in the middle of a swamp, hook onto your belt, have a microphone, and record a news broadcast. That's what it's made to do. The one on the left is not. It's not made to those tolerances. It's not made to that kind of heat tolerance. It's not made to that kind of humidity tolerance. And those things, like, once again, those are data points inside of the observation manual for a reason. Because when you start getting into the environment of your microphone, whether you're talking dust inside of a silo, things like that, all of these things make an incremental difference. All of these environmentals make a huge, not even incremental, huge difference in the end product of your recording. And whether or not what you caught was an actual anomaly or whether it was weight from humidity dew sitting on the end of your electrolyte condenser, not allowing it to move properly, things like that, or even creating an electric short on the backside of the microphone. Because believe it or not, the heat is coming from inside, the coolness is coming from outside, so that humidity will build up inside of the device on the circuit as well, not just on the diaphragm. And once again, once you start getting into some of the issues, potentially causing performance issues, prevent damage, all kinds of things happen with just environmental issues with microphones. So you've got to make sure that the equipment that you're buying, and don't get me wrong, we all start somewhere. We all start somewhere. Right here is a prime example. I have $300 laser distometers. This right here is a very tiny thing that carpenters use. I use it in the AV industry to be able to go, hey, that thing, bam, that's 26 feet away. So that can live in your pocket. You see something that far away in a house, you can get a measurement immediately. This is $30. I have $300 versions that literally work exactly the same. Exactly the same. It may have a couple of additional functions, but I don't think I need like major cubic measurements to find out how far away the tree was that I saw Bigfoot next to. You know, so consider that. Same thing with any audio recorder, that kind of stuff. We have to, yes, start somewhere, but we also need to get to the point of what collects good data as quick as possible. Because otherwise you may be detrimentally gathering data as you go along. You may have numerous things that you could avoid. There was a gentleman just the other day, or yesterday, again, after I made this presentation, disappointingly, who had an anomaly on his phone, was doing a graveyard investigation in Spring, Texas. And he was like, I don't know what this anomaly is. It only appeared on 2 of the images in the middle of the investigation. Took my phone out, took the pictures, stuff was there. Really wild. But it wasn't there on his actual screen. And just from years of working with cameras, sensors, things like that, I immediately recognized the fact that he had an overheated camera sensor in his pocket. Happens pretty regularly with cell phones nowadays. You'll get an alert, especially here in Texas. Go to throw Google on in the car, and it's like, your phone's too hot to use Google. So yeah, what he had was a bunch of colorized pixels all over the place, things like that. It was, to somebody who's done what I've done for years, very obviously a overheated chip on the camera. And to hear somebody accept that, be like, thank you so much. I had never even considered that. And nobody had even considered that as an option in the solutions that they provided. So the idea of being able to move past even using cell phones, and we'll get into that here in a second, because with portable audio recorders, one of the main things is treatment in post-production, how you're treating the audio files, things like that. One of the biggest things, you see that highlighted part right there, that is not actually sound. That's called floor noise. If you've ever seen a movie set, anything like that, where before they say roll, they say speed sound, sound speeds. What they're doing is recording room tone. They are recording the absolute silence of that room, which then creates a noise floor. And then the audio engineer goes in later, takes part of the noise floor and uses what's called spectral subtraction. So you find a 1 to 2 second snippet where it's no audio going on. And this, even if you have a click that's happening, all kinds of stuff, you can use this technique to generally get rid of it. So this is how you use spectral subtraction. You first take a piece of the audio that has no moving audio in it, where it's just noise floor, and you highlight it. From there, you copy it, and then you apply that copied sample to spectral subtraction. Now here's a sample of what it looks like after. You can see how all that noise now becomes generalized noise floor. Here's an actual sample of that exact recording in real time.
From there, I was taken aboard the craft, and I was given extensive examinations and taken to a strange place, and then I was returned home.
Now, you can see what's called the spectrograph, which you can actively at that point see the different levels of audio, their intensity, what frequency range they're in, things like that, to see if it falls within normal speech. Now you'll see me use spectral subtraction, highlight part of it. I will go in and copy that part and select spectral subtraction. Sorry, I didn't really narrate it in real time. I should have. But this is a common practice used to be able to get rid of noise. So now we'll get to hear that.
From there, I was taken aboard the craft, and I was given extensive examinations and taken to a strange place, and then I was returned home.
So you can hear the clear difference between those two samples that are the exact same one. The only difference is one of them has had the spectral subtraction used. So that's just one of the easy techniques that you can do. Like I said, that spectral view is what most people are using. It will give you the actual hertz range of the sound you're listening to, as well as the amplitude and intensity, how loud it was compared to other sounds, things like that. So learning to read a spectrograph really there are some generalities to it as far as dB level, which is your volume, and frequency, which is the actual frequency of the sound itself, or the closest note in some programs. But that varies from program to program that you're using. And actively on my website, curiousresearch.org, there's a page full of free tools, free audio analysis tools, things like that. Some of them are web-based, like the forensic photo is web-based, but you can put that in there and you will actively get to do some of the effects that we're about to use on a sample in here. Now, getting into still and video cameras, once again, this is one of those, as soon as you can step into proper video cameras, proper still cameras, things get a whole lot better. This is an example of Proctor's Ledge rather, in Salem, Massachusetts, where the witches were actively hung. This is a sample of the exact same picture taken with the exact same camera model that has been stripped of filters. So I do astrophotography for fun, things like that, tons of backyard astrophotography stuff. I have a matching camera to my regular camera that has the infrared and ultraviolet filters removed from it. So if there was naturally occurring infrared or ultraviolet in this signal, you would see it, as opposed to the previous one. So doing things like that, where you have matching camera models, but one of them is stripped of filters, or one of them even has other filters attached to it. Matching up time codes, things like that. Those are just a couple of the things when it comes to video and still cameras. But do not forget, your cell phone is not actively a camera. Your cell phone is an assumptive device. Much like a digital field recorder is great. This is a 1 and 0 assumption of the actual sound that happened in that room. This is recording ones and zeros that, as close as possible, replicate that sound. If you had an actual tape recorder, you would be using physics to record those frequencies onto a piece of celluloid, which can be examined in a totally different way and broken down in a totally different way and far less corruptible than a digital file. The issue that you have with your cell phone camera, as amazing as they are, especially iPhones, things like that, is that you have algorithms in there to help steady it. You have algorithms in there to help with skin tone, flesh tone. You have algorithms in there to help with sharpening, focusing, all the things that your unsteady human hand cannot do if you are not a trained camera person. Your cell phone is made to cancel that. Along with that comes artifacts. I don't know if you remember the news stories a few years ago when the S23 and S22s released from Samsung, and people were like, oh my God, look at the moon pictures. And they had to admit, oh, no. Those pictures are actively AI enhanced automatically because the camera recognizes the moon and what you're trying to do. So your cell phone camera is not actively a camera. Your digital camera, as good as mine is, it's a nice one, records all kinds of 4K video, things like that. Totally different than the Canon camera I have that has film run through it. And when you're talking, talk to any photogrammetry expert, they will tell you they want a photographic negative over a digital image any day. And for those of you out there who are movie buffs who may be like, hey, how do they take the Ghostbusters and upgrade it to 4K when it wasn't shot in 4K? That's because a 35 millimeter film frame has more data in it than a 4K image. That's why. There's actively more data in an analog 35 millimeter still frame than from a 4K camera of equivalency. So to think about that, to think about the idea of once you start zooming in, once you start getting into these algorithms, things like that. This is a prime example right here. This is the exact same image taken with an analog camera, analog zoom, or digital zoom at 10 times. You can clearly see all of the artifacting that is there from a 10 times zoom. So if you are using, and we'll get into this in a minute, if you are using your cell phone, don't zoom. Don't zoom. People like me, your photo program, things like that, we'll do a much better job of assuming that data with a wide image that you're then processing to small than by giving them a small image that already has data added to it. So that is something hugely important to consider, especially when you start getting into the effects of interpolation. Interpolation is the way that blocks, pixels, things like that are added to an image as you try and zoom in, as you try and focus, as you try and do these things in digital photography. And right there, increasing image size is generally inadvisable. Interpolation adds information to the original image, which can induce blurriness, artifacts, pixelation, and other issues that can degrade image quality. It's exactly what it says that you should not do with your digital camera on your phone. Zoom in, because every one of those things happen. So we need to take that data into consideration. If somebody says, I shot this with my cell phone, this is another prime example right here of what happens digitally when you start zooming in. You can see where the extra data is added, where shadows are added, things like that. These are all things that the computer chip and the AI and the camera actively interpolates and assumes what you're trying to focus on and do. It is a digital assumption, not an actual representation. So, like we saw earlier, the object luminosity, the blooming on that video of the star. These are the things that happen more and more with digital than with analog once you start looking at that stuff. Lens flaring, ghosting. These are all things that happen from direct light, bright objects, things like that. Noise being added. Here's another example. This is a still frame of this. Another one that was taken in my backyard. That's a great example that many people would say, orb, look at the stuff moving around, everything else. That is the exact same thing as that image. Both of them are Venus. Both of them. So you can see how the bright luminous object that's slightly out of focus, data starts getting added to it. Things like that. So we have to be willing to look at these things. We have to be willing to add this stuff to our data set and consider it. Because once again, all of that feeds into data versus evidence. All of that feeds into our data set, and are we providing the next person, the next researcher, with the cleanest data set possible? You know, if you're using a camera, that's where we start getting into things like color correction, inversion, denoising, sharpening. These are the tools that you use, even convolution kernels. You can see this is what a convolution kernel does, where you actively see raised surfaces, things like that. These are some of the forensic ways that we start using these filters photogrammically in the background to decode an image, to find out if something has been added to an image, if there's a secondary layer on that image, even using things like photo inversion. Now, this is an example of a treated picture. You can see where it's been focused, sharpened, color corrected. You can see where it's been denoised. You can see all that gray noise in there and how it's gone, all kinds of stuff. Same thing here. This is denoise, color corrected, sharpened. Now taking these same techniques and applying them to a paranormal investigation. This is an image that was supplied by a friend of Ryan and I's. She gave me this about a year or so ago. She was getting ready to present, and she's like, I have a case that I want you to look at. I have this picture from when I lived in Washington State of my neighbor's house. And I've always wondered what this thing is, if it's there, if it's a reflection in the window. How can I even tell? I was like, well, send me the picture. So this is the original photo, untouched, unedited. As we start moving into the pre-process and post-process, you can see where we zoom in a little bit. Post-processing, we have one-time zoom plus a little bit of denoising, no sharpening or anything yet. But you can already see the clarity difference just in denoising the image, how close we get to clarity. Once you start adding things like more zoom, more denoising, stuff like that, you can start to get a little bit more detail. And here you can really, especially with things like the known quantitative, we were talking about this earlier during testing, but the known quantitative of how big a house gutter is. This is why unzoomed pictures are important. Remember that idea of forced perspective and perspective. If you have no idea, like again, one of my favorite movies is The Aviator. I was just watching that earlier today. And when Howard Hughes shot the movie Hell's Angels, which was about the flyers in World War I, he actively hired a climatologist to follow them and to find them clouds. Because he was like, my God, it doesn't look action-packed enough because there's no frame of reference. You cannot tell against a flat blue sky how fast those planes are flying. You've got to have something for perspective and reference to the speed. So they needed clouds in the background so that you could see how big the cloud was and how fast they were moving against it. Same thing here. This gives you a prime example of known quantitatives like the size of a window. That's a typical apartment window. So you can assume the size that it's probably about 4 feet high, about 3 feet wide, something like that. Once again, things like typical home gutters, 4 to 6 inches wide, things like that. So that gives you a much better fair to midland idea of the actual size of the object in the image. Once you zoom in a little bit more and do more denoising, do a little more sharpening, and then finally add one of my favorites, embossing. Embossing is an interesting one because what it basically does is it finds the edges that are there and creates shadow for you to let you know that object has actual space and dimension to it. So we can tell right here by the shadowing on the backside, by this deep shadowing here that very much looks like an actual socket where the middle is popping out over the background. That is depth. That's light depth on there. That's shadowing on there. So we know this is there. Whatever that object is, it may well be, like I told Ryan earlier, the guy may be a General Grievous fan from Star Wars, and that's a General Grievous mask hanging on his wall. Who knows? But we know it's not a reflection. We know our friend isn't crazy, that there was something there. Whatever that is, we don't know. But through these simple tricks of photogrammetry, we can get to the point of at least something was there. From there, we poke and prod more, we experiment more, we go through science, we do more study, we do more experimentation. But once again, through simple techniques like this, you can find out a lot of data. Beyond that comes the real juice nowadays. That's the EXIF data. Anybody here familiar with EXIF data? This is where it gets real sexy, folks. Real nerdy and sexy. EXIF is literally the data that every single digital camera puts on every single image. If you have the location on your phone on, the GPS coordinates of that picture will be on it. It will tell you the exact camera model it was taken with, the exact time it was taken with. Once again, the exact location, even the direction it was facing on some cameras. This is embedded in every digital image coming off a camera. The only way for it not to be there is for somebody to wipe it, for somebody to deliberately go in and get rid of it, or to set their camera to not have it on there. One of the two. But this is a big one. And this is a real easy way to bust a lot of things, a lot of stuff. If you recall a few months ago, if you follow the UFO UAP trail, folks, there was a big issue with Lou Elizondo at a conference showing an image that came from, quote, vetted sources, his vetted intelligence sources. It ended up that photo was actually a picture of a chandelier in the mirror of a hotel, or in the window of a hotel. Somebody shooting out of the window over the street, and you could see the chandelier and the reflection. That was found out from EXIF data. And not just the EXIF data, but from a very simple back search on the internet. John Greenwald from the Black Vault, as soon as that picture was posted, within 10 minutes, had it busted. It was like, that did not come from that. It came from this image, and showed the original image. So it's pretty easy nowadays to find this stuff. Once again, here's a great example of actual EXIF data off a photo, where it gets into the camera that it was shot with, the actual settings on the camera for ISO and the lens and everything else. These are some of the things that if you submit a photo to MUFON, this is one of the first things they do, is find out if you actually took that picture or if you generated that picture. And there are tools out there, like I said, the photo program that I have on the website will actively tell you if that photo has been doctored. It will tell you if there have been layers added to that photo, things like that. So the investigations go deep. And when you start looking at things like EXIF data, metadata is what most people know it as. What your government is always getting from your phone, just simple metadata. But metadata tells a huge story once you start digging into it. And of course, I don't think we could really talk about examining data in this modern light without discussing AI. This is my Loveland frog. I'm a Midjourney freak. As you probably noticed, there were quite a few Midjourney created images in this presentation today. I use Midjourney. You can tell with a lot of AI images, you can find discrepancies. This is quite obviously a fake image. I don't think I could post this one on social media and get away with it. Hey, I got a video of the Loveland frog. Probably wouldn't happen. However, you tell somebody I ran across great-granddaddy's picture at Bohemian Grove, that's a different story. This dropped 3 days ago. All over the Bigfoot groups, all over the place. And it's interesting sometimes. I like fly on the walling. I frequently will not comment. I frequently will not comment on things like this. But I love reading the comments. The people that are like, my God, what kind of mutant mule white moose deer is that? Because that deer does not match any breed of antlered animal in North America at all. So it looks real enough. But once you start digging into data, once you start digging into EXIF, things like that, you can find out real quick that it was not taken by a trail cam. You know? And we have to be willing to address this. We have to be willing to look at the ethical side of these things. Even at the ethical side, as Curious Research, I literally just built a research AI machine. Standalone, no internet connection, tiny little supercomputer that is there to just ingest data and spit things out. But you have to be careful with that. You have to be responsible with the data. And you have to be willing to cooperate with other people. You have to be willing to collaborate. It comes down to collaboration all the time, forever. Once again, we did not get to the moon alone. What got us to the moon, what got us robots on Mars, what got us cell phones in the palm of our hands, healthy competition. Healthy competition. The need for things to be somewhere and literally saying, we need this made, we need this to happen, let's all get together and pull on the same weight. And with things going the way they are right now, with things moving the way they are in society and technology, things like that, it's interesting to see where we are right now, where we will be in the next few years, and what issues are going to be facing us as investigators. Because once again, the world of AI, I now have an AI voice that is me. It's me. There's maybe 4 people that I know right now that could spot the difference between that AI voice reading something or me reading it. That's how accurate it is. That's how real it is and how accessible it is. I pay $5 a month for that model, man. I could be making content with my voice. Other people could be making content with my voice, and you would never actively know it's not me. The world of deep fake, and there's software out there for that too. To be able to detect deep fake, to be able to let you know that images like this, images like Grandpa's image from Bohemian Grove are fake, that they aren't real. And if you were to zoom in on that picture, you'd notice all kinds of inconsistencies. You'd notice a lot of people with like 3 fingers, for instance. Like an unusual amount of people with just 3 fingers. You know, we're like, what was happening in the early 1900s? That like every third dude has 3 fingers. But once again, if you're not looking at it critically, if you're not willing to look at it critically, you can be taken down a lot of roads that may, much like the 3-eye atlas images right now, be leading you down wrong roads and be leading you down a road of even fear-based stuff, you know, and continuing that fear-based model, to loop it back to the beginning of science versus us, and the idea that it's a versus situation to begin with, when it's not. We are all in this for the same reason. Scientists are in all of this for the same reason. They want questions to what moves the universe. We may have them, but we have to be willing to bring our data to them in scientific ways. We have to be willing to adopt their nomenclature. We have to be willing to meet them in the middle. For people like our friend Rod and Ryan over here, the advice I give to people who are cryptid hunters all day long, if you're out in the woods squatching 3 weekends a month and you have 5 trail cameras, contact your local biology department. Let them know your location. Like, they'll put a study together because they don't need grant money now. They have you, a citizen scientist, out in the field who's willing to Dropbox them pictures every Sunday when they come back from squatching. They may be trying to count white-tailed deer in that area, birds, bears, all kinds of things. But now that you've shook their hand and you're giving them data that they can use for their programs and everything else, now when you come to them and go, hey man, you know those pictures and videos I've been sending you? I just got a weird one. Do you mind looking at that for me? And now you have a set of actual scientific eyes on your data. That's called social engineering. Just so you know, anybody here familiar with Better Call Saul? I love that show. One of my favorite characters was the lawyer who was friends with the banker. Every time he came in with, oh, I got cake pops today, Linda. Oh, these are sin. I'm telling you right now, they're sin on a biscuit. Watch out. But what he was doing was that slow and steady process of getting her so used to seeing him and so excited to see him that she didn't have questions about why he was there with a suitcase going into the safety deposit box every week. So, yeah, you can kind of use the exact same technique to get your way into science by providing them with what they want, with what they need that you already have. You have tons of data out there. Give it to them. Let them know that you're there to help them in their scientific cause. And when yours comes to the cause of science, they will be there to help you, because that's what research associates do. And by doing those things, you've immediately lifted yourself to the world of citizen scientist in their eyes, which is totally different than paranormal researcher, even though they are intrinsically the same thing. Because once again, as soon as you've had an experience, you are a citizen scientist. That process began, whether you like it or not. The Field Observation and Encounter Log is one of the many books that we've written. It's available in the back. The whole purpose for this is to prepare casual investigators that are out there. It's big enough to fit in your back pocket if you're a squatcher leaning against a tree. It's big enough to put in your backpack if you're a paranormal investigator, things like that. The idea is to be able to have a dedicated scientific way to take data down. Location data, humidity data, temperature data. Things that when you're looking at things like, hey, what camera did I use? Things like temperature and humidity immediately come into spec, and as to whether or not that equipment is malfunctioning. So These things are important to science. The example I give is a picture is not worth 1,000 words. It's only worth 1,000 words to somebody who's been in the situation that the picture is of. If you show a 4-year-old a picture of a wedding reception and he's never been to a wedding, you have to explain what a wedding reception is. And you're probably going to have to explain what a bride and groom is, what a wedding is, what they're all doing with their hands in the air. You're going to have a lot of questions to answer because the picture alone is not worth 1,000 words to somebody who has not been in that situation. So if you have pictures, if you have videos, if you have audio recordings, the data behind it is very, very important. The way in which it was gathered, the technology used to gather it. We also have the remote viewing session journal. You can find all this stuff at curiousresearch.org, everybody. Thank y'all so much for your time tonight. Thank y'all for your support continued for quite a few people of Symposium of the Strange. It's been a great year, and we look forward to another year of events. So any questions before we end the evening? No? Any comments? What you got, Rod?
I use the term trace evidence a lot.
Okay.
Can you break that down as far as being in the field and using that term in terms of finding like what, you know what I mean?
Yeah, the question was trace evidence and using the term trace evidence, which I'm a fan of. I'm a fan of trace evidence because that is actively a field terminology for investigation of forensics. So the trace evidence basically comes to the fact of you have big chunks of data. You have the trace evidence comes down to things like we found a slimy fingerprint on a window. We may have alleles from skin oils. That's trace evidence. Trace evidence would be things like we found a hair in our Bigfoot track. When we pulled the track out of the dirt, we found a hair in it. Things like that. Those are trace evidence, which yes, are absolutely points of data or points of datum in a data field that should lead you to bigger and better investigation. That yes, are evidence. They are evidence of something. And that's just it. Like we know, and the reason why it's called trace evidence instead of trace data at that point is because we know something that had hair left the hair. The only true anomaly is what left the hair, not where hair comes from or what is this. We know what it is. We know it's a hair. So we already have that data. We have enough data to point to the evidence that this is a hair. So that's the differentiation between data, trace evidence, evidence. It's the fact of some of it has already met, even in the field, the point of datum to data. So great question.
For some of us that are field investigators that need to have the funds to have things analyzed, do you have any resources where we can go to that may be offered for no cost or?
I am working on that presently because yes, that is my loving wife asked me that just before my last conference where I spoke at. Where those are still answers I'm working on right now, my friend. I've made a couple of friends in Texas Parks and Wildlife. They're mainly marine biologists, but I think the last part of that is important. Biologists. They still have access to the same labs. They still have access to the same phlebotomists, things like that. So even getting someone like that who's willing to say like, hey, you know, my cousin came across this. You mind looking at it for me, buddy? So yeah, we're still working on that. We're still working on building those bridges with some universities, some labs, that kind of stuff. What we do have, if you visit our website, curiousresearch.org, go to the store, down at the bottom, we not only have tons of equipment like this, mainly lab grade equipment that you can get actual readings off of, that you can zero, that will record readings while you're in the field. But we also have a huge cadre of forensic material there. Things like actual plaster casting material, fingerprint lifting kits, DNA lifting kits, sterile bags things like that, like things that are actually accepted as evidence bags, that kind of stuff, where it's like, here is a sealable bag that comes in a sealed bag that's hermetically sealed. Because that's a very, very cogent question, man. And a lot of the reason why I started Curious Research and why I talk about the things that I do is because it's something that, are you even gathering the data in the field right?
Yeah.
Are you treating that piece of forensic material in a way that and have a chain of custody written down as to who took the picture, who was there when you took the picture, who was there when you gathered it, things like that. A lot of those things are in the manual. Like there's a spot there, were there other witnesses? What are their names and phone numbers? Things like that, so that you can follow up with people. Because, hey, you know as well as I do, you may be out on an excursion with 3 or 4 people on the weekend, and you may not know 2 of them because they're just friends of friends that came along and heard that's what you're doing, and let's go out and do this thing, buddy. So, but yeah, the actual forensic collection of data, making sure that you're collecting it in the most forensic way possible, using plastic gloves, making sure that you're using sterile objects, not just grabbing a stick from the woods so that you don't touch it. What if a bear peed on that stick? Now you have contaminated it with bear urine. So unless you know the story of the stick, don't use the stick. Literally.
Yeah.
So yeah, when you know that like this popsicle stick came out of a sterile bag that was hermetically sealed, you have a pretty 98 percentile confidence at that point that you're going to be okay and not contaminate things further using that stick. Yeah. Young man in the back.
Me?
Yes.
So I just want to say, I actually loved it.
That's great.
It was a great performance.
Thank you. I appreciate your congratulation and support. But all of this comes down to the fact of open heart, open mind. You know, we've always got to keep an open heart and open mind, and understand that even open-heartedly and open-mindedly, when once again what is in the red circle is found, that it doesn't remove our experience. It doesn't change that moment that somebody shoved a crowbar in our keyhole and widened our field of view through that keyhole. So that's where I want to leave everybody, is the fact of, yes.
Would there be a way for you to show a photo I have up on the screen and get like your
That might be a little tough
yeah, I don't know.
offhand, but I can definitely look at your photo afterward. So yeah, but yeah, it's one of those, we've got to be willing to look at things. We have to be willing to look even at our own experiences. I joined the seminary after a religious experience at the age of 16. Should that experience be later proven that it was like a petit mal seizure or something? That doesn't change the day that I had that experience and that I was called to do that because of that experience. That doesn't change anything. Just because what's in the photo or what's in my experience has been proven to be something else. Because once again, our filters take us to those places. That's what changes things, is the way that we process data, the way that we look at them. So I hope everybody got something out of this tonight, and everybody is able to look at their data and look at other people's data in a whole new light. Not only with open hearts, but with open minds. So thank you guys so much. Greatly appreciate it.